Okay. All right. Making a new movie. I did have one from last year, but it was done differently. So I'm gonna get this on YouTube and all. But hey, before we go into what you're supposed to already have done, and if you haven't done it, you're a bum and a charlatan. What's anything to the zero power? Anything. One. So there's simple things we got to know. Then write this up here. You already did. And then let's do this the common sense way where are there more x's? Very simple. Where are there more x's? On the bottom. How many more? One. So we would know that this is x and x, and this is x, x, x. All right. And then these would cancel. Oh, okay. Well, then the logical way of doing this is I'd have 1 over x left over. There's more x's on the bottom. But then there's a rule that says you could take your exponents and subtract them. This creates the negative exponent rule. So we could simply try to do it this way, and then we end up with x to the negative first. There's the rule. That's why the negative exponent rule is considered the flip rule, and then turn that power into a positive. It's because of this, because it's true. If I had x squared over x to the fourth, it'd be 1 over x squared or x to the negative second. They're equal. So that's why we need to recognize that. So what you were supposed to do on this was do these limits, but really what you're supposed to do is input, say it. 8 to the 0 is 1. 8 to the first is 8. 8 to the negative first is 1/8. That should be enough in order to know that this is. Okay, there we go. I got to turn that feature off, which I don't know how. All right, so that's why I always forget. But anyway, you got that horizontal asymptote because as I plug in negatives, it just becomes a fraction. So as x goes to negative infinity, you should have put 0. As x goes to positive infinity, inputs, outputs. That's where the outputs are going, positive infinity. Inputs, outputs. Okay, that's getting the 0 when I input negatives. Some people still can't do these limits. Drives me nuts. Wasted points. All right, now that's why I went over the negative exponent rule. One way of thinking about this is 5 to the negative first raised to the x. And that's an exponent rule. When you have multiplied exponents, that's the power raised to a power rule. We'll have to get into that as we dive into these graphing exponential functions. And then negative exponents mean flip. The reason you kind of have to know that is because then you know that the graph looks like this. Input 0, I still get 1. I input 1, I get 1/5. I input -1 and I get 5. Flip. So that's 3 points. That's why that is the minimum. We're going to make you, when you're graphing these, you have to at least show 3 input-output values. And it shouldn't be hard. It really shouldn't. All right, but anyway, horizontal. So as x goes to negative infinity, y goes to infinity. As x goes to positive infinity, y is limited to that asymptote. That's why these are the things we should know. Then I'm going to be lazy on the last one, but not at first. You have to know 0.25 maybe is a fraction. So it's 1/4 raised, to the negative x, and then the negative power flips. So ultimately, this is very similar to number 1. So here's the laziness. Don't ever do this on a test. But it's those limits, because it's the same type of shape. Fumble. Okay. Are you okay? Ooh, I just got to stare. All right. All right. All right. Now, uh, so we already went through this Friday. So just quick synopsis. You already have this in front of you. Instead of y equals b to the x, I just put like a concrete value there just so you can input. Say it. 2 to the 0, 1. 2 to the first is 2. So that's what b is replacing. 2 to the negative first is 1/2. So anytime you have a base bigger than 1, you got that action, that graph. It's increasing, concave up, so on and so forth. Over here, what I lost there is y equals 1/2 raised to the x. All right, probably didn't see that yet anyway. Anytime a number is in between 0 and 1. First of all, 1/2 to the 0 is still 1, but 1/2 to the first is a half. So B is, I'm just putting a half in there so we can think about a number and think about what happens. And then when I plug in -1, 1/2 to the negative first is 2. So that's where it starts getting larger. That's why this is decreasing. Blah, 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 blah. Maybe a note to self, maybe circle this word bounded below what? These words. That's because I have a boundary below. I don't think that's really tough. There's a boundedness to this graph. It's bounded below because it doesn't get any lower than that asymptote. So it has a boundary. I don't know what else to tell you. Sometimes that terminology comes up, so just making sure. You could read all the rest. We talked about this Friday. Not we. I played the guy on Flip Math. You can have various different limits. It either goes off to infinity or negative infinity, or 0. But that's going to change because we're going to shift the graphs, and that should not be a big deal. You could do this later if you wanted. You don't see the colors. I'm not going to print your notes in color. More money, down the drain. But we should know these reflection components or transformations total. Okay, so up, down, right, left shifts for sure. The up, down shifts are going to be the biggest. The up, down shifts, my knee just gave out. Just making one little shift. I was making a little shift in my body. My knee just gave out anyway. But those are going to change the asymptote, obviously. So you're not going to be at y equals 0 anymore if you have a plus or minus d value. All right, vertical dilations, of course, x-axis, y-axis reflections. Be careful on that. And actually, for y-axis reflections, if you exercise the negative exponent rule, you'll see it. It flips the graph. That happened on this one. 5's the base. That should be increasing. But with that negative x, it flipped the graph, and now it's decreasing. Right? So that's another way of looking at it, but that's a flip over the y-axis. Instead of increasing, it's now decreasing. So we can manipulate that in any way, shape, or form. So when we look at this, these are identical transformations, but this is a quadratic. So that would be a u. But now I have an exponential with the same numbers. So these have the same transformations. This is a flip over the x-axis. Reflection's a better math word. 2 isn't. This 2 is good. It does matter what the base is though. But that's not really a transformation. But that 2 out in front, which is not the base, is a vertical stretch, if you had to say the word, or vertical dilation by 4, which implies a stretch. And then, of course, this is 3 left. And, of course, this is the most important 4 down. So that would have a horizontal asymptote at y equals -4 is the expectation. Really actually should graph that one at the end, but we don't. We kind of keep it simple here and then ask you to do 2 on your own that are a little bit more of a challenge. Shouldn't be bad. Okay, I'll probably fill this stuff in at the end as I plug in some points. In the note purposes, I'm going to do 5 points. In your homework, you should at least have 3 points. And your test or quiz coming up, which I don't know when that's going to be. We're in 2-3 right now. It ends at 2-4, so it could be close. Could be this week. All right? We at least have to have you have 3 points. And here they are, and I'll go back and answer these after. Well, I guess I could describe the transformations. And then is this growth or decay? Well, we got to be careful. I have a base of 2, so that should be growth. But then I'm multiplying by a -4. What does that negative do to the graph? What does that negative in the front do to the graph? Flips it over the x-axis. So now it's below the asymptote. So I'll answer that at the end, possibly. But the transformations are what I just said there. Flip vertically, a vertical flip. And then stretch vertically, a vertical stretch by 4. Probably going to ignore these on the rest of them. maybe I'll verbalize them. You could say vertical dilation by 4, and the number 4 is by default the stretch when it's greater than 1. Okay, but that's fine. Horizontal asymptote, well, guess what? We're going to find out that horizontal asymptote doesn't change. I don't have an up-down shift, so it will be at y equals 0. Now I'm going to get the y-intercept right now, because here's the first point that always should be right in the middle of your chart. It should be the 0 exponent point. What gets my exponent to be 0? What's the answer to that? What would I input in that one? 0. It's not a trick question. It'll be different later when we have right-left shifts. So when I plug in 0, but now I wrote this all the way back in August, our first day together. Anytime we input output, we got to follow PEMDAS rules. So parentheses exponents. So I do 2 to the 0 first. That's what is 2 to the 0 power, everyone? 1. What's 1 times negative 4? So there we go. We got that change. We got that 0 comma negative 4. That was supposed to be 0 comma 1 for the parent function. So we already see that we have a flip, and then then we'll see some other stuff here. I don't want to get ahead of myself. 1, 2, negative 1, negative 2. You go by ones before and after the 0 exponent points. All right? So 1, 2 to the first is 2. I'm not writing any of these down. 2 times negative 4 is negative 8. Uh-oh, that's getting pretty large, negative. And then 2 squared is 4. 4 times negative 4. Okay. Just by those 2 points, I see this is going nuts. I can't even graph the second one. Oh, I actually did that at 9. Can't see. 8, negative. And then the next one's off the screen. So this is where the graph starts taking off. That's what that negative in front did. It flipped it, and now it's taken off to negative infinity. And then maybe a couple points here. Maybe I'll write this one. What's 2 to the negative first, everybody? What's 2 to the negative first? 1/2. Everyone should know that. We've established it. I wrote it up here. This is the things that I complain about. Things don't get memorized. All right? And then we keep making the same mistakes over and over and over again. It's my number one complaint with this class. It really is. We've got to lock things in and move on. All right, half of negative 4 is negative 2. And then, so negative 1, negative 2. Okay. Let's see what the next one does. Negative 4 times 2 to the negative second, which is negative 4 times 1 over 2 to the second, which is 1/4. Okay, so 1/4 times negative 4 is negative 1. Okay, I could see the action happening here. As I plug in more negatives, that fraction's denominator gets larger, which makes this very small as my outputs. If I went to negative 3, this would be 1/8. 1/8 of negative 4 is negative 1/2. You're not falling asleep. I'll wake you up so quick your head will be spinning. All right, so there is still, remember the Samuel's alarm clock / sleeping device? If you have troubles, sleeping, I teach on one button that you press. The other button wakes you up. Samuel's calling you a charlatan. All right, domain, all real numbers. You can take any number to any power, decimals, negatives, positives. But now when we look at that picture, the range is definitely different. It's negative infinity to 0 now. Look at the picture. I didn't realize this on with the other class, our limits got pushed to the other page. See those there? If you want to rewrite them up there, that's fine. The other class, you know what? I did do that with the other class. Fine, we'll write it. If you want to flip it and write it. But I'll rewrite it up here. As x goes to negative infinity, input, say it. As I input these, that's where my output's going to, 0. And then input, say it. As I input, that's where my y's are going. So some people have still missed every single one of these all year long. I don't know what you're doing in here. Sorry. We can't get these limits right. I just got it wrong there. Sorry. I don't know what you're doing in here. Constantly missing these points. I don't know what's happening at that desk of yours. Okay. Those that are missing that over and over and over again. Don't know what's happening. Input, say it. Output. Okay, now all we know is this, and I'm going to add this again. Your minimum job is to fill in these 3 points. I just like going a little bit further. Okay, parent function growth or decay. What will that be? What do you think that'll be? 1/2 raised to just x plus 3. Growth or decay? Decay. Did I go back and tell you this one? This is technically decay, but they do have this weird thing that they say this is growing negatively. So sometimes we argued with our group that this is a growth, like the national debt. You know what's happening with the national debt? It's growing horribly. So the debt is growing. You know what I'm saying? So the negative number is growing tragically very fast. So I'm really worried at some point some generation's going to pay the price for that. I don't know which one, but it's getting pretty bad. So 3 left. Don't scare the children, Mr. S. All right, and then there's no up-down shift, so we're going to see a y equals 0 there. We'll see it. We'll see it in the charts. And then the y-intercept, we'll hold off on that. Don't let me forget about this. Okay, but now here's my question. Got to focus. All right, I caught you. All right, what makes this exponent 0? Inputting what number? -3. He didn't listen to that question. -3. The ID guy. Okay, what's -3 plus 3? 0. What's 1/2 to the 0 power? So -3, 1. So that 0, 1 point got moved 3 left. That's the only effect that you see. That's it. And then -2, -1, -4, -5. You just want to go one each way for the yellow points there, the ones that you're only responsible for. Hey, and this is easy. -2 plus 3 is 1. 1/2 to the first is 1/2. So, okay, that's showing me that I'm getting closer and closer. So -1 plugged in. -1 plus 3 is 2. 1/2 squared. So 1/2 to the -1 plus 3 is 1/2 squared. That's 1/4. 1 squared, 2 squared. Square the numerator, square the denominator. This is not rocket science. Did I find the y-intercept yet? No. So the y-intercept is 0, comma. When I plug in 0 for x, I get 3. 1/2 to the third is 1/8. So I could still find it even though it's not on my charts. It's simple input outputs. These are the things tragically going wrong. Students not knowing how to throw in numbers and evaluate. Tragedy. -4 plus 3 is -1. What's 1/2 to the negative first? What's the answer to that? 2. Either get it or you don't. There is no I'm so confused. Either do it or you don't. Blah. All right. And then -5 plus 3 is -2. 1/2 to the negative second is 2 to the second, which is what? 4. So this behavior right here is showing me, okay, when I keep plugging in these negatives, these start taking off. 1, 2, 3, 4. Okay, so I got my action here. This is doing that, and then this is approaching a boundary still of y equals 0. So that expectation held true from what I put in the answers up there. This is not hard, all right? I don't care what anyone says. Input, say it. Output, what I inputted was big X's, and I got 0 for my output. And then input, say it. When I input these negatives, what kind of Y values am I getting? Large positive. Some people have missed every stinking single one of these limit statements. What is happening? All right, domain is always all real numbers. Range is 0 to infinity. Me making those comments, those are the people that hate me. I couldn't. Anyone? Care less, because there's X. There's expectations. You got to get something going on here, man. Someone's got to wake up and smell the coffee. How many people like coffee, by the way? Nobody's talking to me. Like rabid dogs. That's what I teach. Okay, what number should I plug in for the zero exponent rule? Did I miss something? Oh, I thought someone was raising their hand. What number should I plug in for x to get the zero exponent? Zero. Okay, seems like a trick question. This means I don't have a right left shift. And then what's 2 to the 0 power? I'm not writing this down. What's 1 minus 4? So the 0 comma 1 point went down to 0, negative 3. There's the 4 down. 4 down. But then if it's only 4 down, I can expect growth. I don't know if I wrote that in the other thing. Then the horizontal asymptote, okay, we should expect 4 down. So we should expect this, but maybe it's not a question mark. This is right. Just you might not know this yet, but we'll see it when we have the X. What's the matter? Ah! Sorry. That's part of the alarm clock. When someone sleeps, the Samulus alarm clock. All right, anyway. Okay, there we go. There we go. Good luck in college. When you got 3 classes in one day and it's lecture, lecture, lecture. Good luck. Good luck. All right, 1, 2, -1, -2. Maybe write some of these, but not the first one. 2 to the first is 2. 2 minus 4 is -2. 2 to the second is 4. 4 minus 4 is 0. Will you see, this is the part where it starts taking off. Maybe not so much, but I think you could kind of tell. It's because our base is only 2. But if I went to the third, 2 to the third is 8. 8 minus 4 is 4. Now it starts taking off. Okay. So we should be able to see that from those 2 points there after the 0 exponent point. And then -2 to the negative first. Fine, I'll write it for movie purposes. Is 1/2 minus 4. This is where we start getting the decimal. 1/2 minus 4 is -3.5. And then 2 to the negative second for that second input is 1/4 minus 4. That's -3.75. So guess what you're approaching? What are you getting closer to? -4. Okay, that's why we have that asymptote there. So we see that just by doing this as decimals. This will never get to -4. It's impossible. All right. It'll get close though. All right. So anyway, there's that graph. Domain always all real numbers, but then the range is changed. Yes, the range is changed from -4 to infinity. Sorry, I was thinking about a different one there for a second. As x goes to negative infinity, here's y approaching -4. I hope I did that right in the other hour. And then as x goes to positive infinity, that goes off to positive infinity. Some people have missed every single one of those. I don't understand why. Is this the last one? And then you have to do them on your own? All right, last one I blabber about, and then during the video, I'll walk around and then see if anyone's sleeping again. Oh, he got his water. Maybe that wakes him up. Water, water, water. At least he didn't crinkle it. Oh, now he did. Because he had to. It had to be mentioned. Okay, what's the zero exponent rule? Or no, sorry, what's the zero exponent number? What do I plug in to get 0 for the exponent? 2, some people have said. 2. 2 minus 2 is 0. 3 to the 0 is 1. So all that happens is this gets moved right to, wait a minute, that's weird. I see a positive 2, which usually means left. It's because I didn't rewrite this. 3 to the negative first times x minus 2. I took out that negative exponent. And then just like I told you, the negative or power raised to a power rule, I can kind of think of it like this. This is actually going to be synonymous with graphing this 1/3 to the x minus 2. So I know you don't have to do that, but if I just input output in the original, you'll see the action that this is acting like a 1/3 raised to the x minus 2 to right. So this is going to be decay because of that negative exponent rule. I'll prove it. Plug in 3 and 4, and then you get that negative exponent. 2 minus 3 is -1. 3 to the negative first is 1/3. There it is. I'm already approaching 0. 2 minus 4 is -2. That's 3 to the negative second, which is 1/3 to the second. Oh, man. You're already getting really, really small, but you will never get to 0. Ever. No matter what you plug in. Okay, and then 1 and 0, that's where I get my positive exponents. 3 minus 2 is 1, 3 to the first. 2 minus 0 is 2, 3 to the second. Okay, that's where we get the big numbers. Oh, and I do have my y-intercept. So 0, 9. Sorry, going back to the previous one, I don't think I identified the y-intercept, but it's right there. The y-intercept happened right away. Oh, any other things I missed? Not really sure. Growth. So yeah, those are growth. I don't know what I'm. Okay, and this will definitely be decay from the points that I see here. And make sure I hit them all. All right. And domain, all reals. Range, 0 to infinity. No change in the range compared to a parent graph. As x goes to negative infinity, here goes y to infinity. As x goes to positive infinity, y is bounded. Boundary. Okay, now I'm going to walk around. Go ahead and do the next two. And then I'll move this right here and just reveal and then get a double reveal. Nice. I like how that focus is better right there. Okay, I'm going to walk around the room and see what the bums are doing. What do you got the graphic? Let's go. Oh, you know what color it was? Is the right one? This one right, and it's steamable, right? That's right. Yep, that always is the case. Good. I had to put that so that you got motivated to turn it in. Otherwise, I'd forget. I would never remember. Uh-huh. It's flipped over the x-axis. Yep. Okay, 18 is the right number, so good. We'll be with you in a minute. It'll eventually get in there. Feel free to remind me if I don't get it in there. From time to time, sometimes. Okay, so what they're doing is this, and then I'm about to reveal as I walk around. They're doing this one right there. So 8, 9, there's 2 more after the U tries part. This one? People usually get that one fast. Should be getting pictures. Hey, and then the second one, the graph is arbitrary, like where you want to put the x-axis. Give you a lot of lines because the input and outputs we get pretty large sometimes. Yeah. Picture yet? Get that picture. Oh, they put up that picture. Yeah. Are you seriously? Same. I'm sure zero. Just one. Zero. Zero with one. Because it's one. They're still going. Hey, I'll reveal the first one for the people watching at home. This video gets activated. Okay, we're gonna show the first one. I'll stand up here like a maroon, talking about all the things, and we'll label all. I'll verbalize all the stuff. But there's your input. Feel free to do your chart up, down, or right, left. First number you should plug in though is -1. -1 plus 1 is 0. Now you got a bunch of stuff here. PEMDAS. 1 after the 0 is 1. 1 times 4 is 4. 4 minus 2 is 2. So -1 comma 2. Then 0, 1, -2, -3. If you only want to do 3 points, fine. If you get it. When I plug in 0, I get 1. 1 half to the first is a half. Half of 4 is 2. 2 minus 2 is 0. Again, PEMDAS. Parentheses, exponents. It's actually exponent. Then multiply, then subtract. Shouldn't have to do much more than that. 1. 1 plus 1 is 2. Half to the second is 1/4. 1/4 of 4 is 1. 1 minus 2 is -1. Now we are approaching, hopefully you got this down, the down value, that's your horizontal asymptote. I'd have to keep going to see the fractions happen. That's what that multiplier of 4 does. All right, so anyway, -2 plus 1 is -1. Half to the negative first is 2. 2 times 4 is 8. 8 minus 2 is 6. We're already getting pretty large there. -3 plus 1 is -2. Half to the negative second is 4. Now we're getting big. 4 times 4 is 16 minus 2. So that's why the graph is what it is, so we can fit those points down. As x goes to infinity, y goes to positive infinity. As x goes to negative infinity, y goes to -2. Domain all real numbers, range -2 to infinity. Walk around one more time and I'll reveal the next one. We need to get those values though, at least those 3 for -2, -1, and 0. Got to be able to plug those things. That's how you do it. To be -2. If it's negative, it's negative. It's a positive. Yeah. Like to right? No way you said it. So what do you say? 2.
No, I think that is.
-1.
I'll go there. -1.
Oh, you read
Read one. Oh, wait, where's it? Green. 2 make up. Okay.
Yes. Uh-huh. You guys are cheating. You should do this by hand. Right? You should be typing it on there. Right? Yeah. So you should be plugging in 2 first. What's 2 minus 2? What's 2 to the 0? But that -1 plus 4 is what? What you doing? Come on, man. Got people typing input outputs on their calculator. They shouldn't be. They shouldn't be. Just waiting for the answers. You didn't get anything out of the notes? There we go. You can name them, but I just okay. That's what you can put around the yeah. So just to make your points fit. Huh? No, That's not a parabola. So you got an output value incorrect. All right. Walking around, we got some troubles. Okay, so here we go. I'm gonna just show this equation real quick. PEMDAS. What's the first number we should be plugging in? Some people have nothing. They're just sitting and waiting for the answer from Mr. Samulus. What number should I plug in? Not 0. I should plug in 2. 2 minus 2 is 0. What's 2 to the 0? Answer the question. 1, but then it's negative, right? The negative is like a multiply of PEMDAS. It's not part of the exponent. What's negative 1 plus 4? 3. That is our point. That is our first point that we should have. So or 2, comma, and then you go 3 and 1 at least. And now evaluate what happens with 3 and 1. I need you guys to do this though. Some people are just sitting here waiting to. It doesn't matter where you've been. You could have been. This could be your first day in my class. You should know what's going on. It has nothing to do with prerequisite stuff. Nothing. Right? Still got 10 minutes.
I leave that. Yes.
Okay, I do want you to get your own accomplished here. Give it time. Give it time.
No. This stays. This minus base. Yes,
You got one absence. What's it? Lincoln one absence. We're at 0. Before turning on 3. So 3 absences so far on a Monday. Good. I don't want to show the answer too quick here. Some groups moving along here now on their own. I want to make sure we get some success. Look at me and then me right there.
Three times 3.
Don't forget your compass is a home port today, right? Fire drill. Okay, enough of the video here. How many people have this picture, huh? Okay, so where's the x-axis? We were just giving you like power to put it wherever you want in case the numbers get really bad. You might have to move the x-axis way up. Okay, but input output, I circled the input outputs we should have done. 1, 2, and 3. 2 because what I told you. 3, real quick. 3 minus 2 is 1. 2 to the first is 2, but then it's negative. Negative 2 plus 4 is 2. That's why I get 3 comma 2. And then 1 gives me the first decimal. 1 minus 2 is negative 1. That makes 2 to the negative first a half. Negative a half plus 4 is 3.5. There's the approaching of 4. 4 up. All right. Could keep going. Whatever. If they did ask the y-intercept, you'd have to plug in 0. 0 minus 2 is negative 2. 2 to the negative second is 1/4. Negative 1/4 plus 4. As x goes to infinity, y goes to negative infinity. As x goes to negative infinity, y is bounded. By the way, this is bounded above, boundary above. Not really hard. All right. And then all real numbers for domain range is negative infinity up to 4. Okay, very simple there. All right, we'll end the movie. There was a lot of, oops. Oh, new calendar. Okay, so I did do that. Here's my calendars. No, that's too new. Here's the old one that says this is no longer valid. All right, this doesn't. It's only good for this year. That idea. I don't know how to stop this video. Where's the thing at? I don't know where the stopping the video is. Was this video even going? Oh, here it is. It moved all the way over here.